Good day, students. You are welcome once more to Nelstar Tutorial. My name is Justin Wata. This is my number. I will handle you on the following courses you can see on the board. A total of 15 courses. General Mathematics, O level, Physics O level, Chemistry O level, Basic Programming, Additional or Further Mathematics, Computer Science, Statistics 1, Calculus 1. The Maths A level I take in Pure Mathematics, Statistics 2, Mechanics, then Calculus 2, Calculus 3, Differential Equations and Advanced Differential Equations. So today, we are going to look at the sixth subject here called Computer Science. Everybody knows that this period, this era, is what we call the computer era. We came to as at now, we are all used to different forms of computer around us. But some of us may like to be interested to know this computer. How did you start? What are the various technologies involved? Where were we before we came to where we are today? The earliest computers used to be so large, so hard that for you to install a computer, you need a room that is up to as big as this. A room as big as 12 feet by around 12 feet. A room as big as this before you install a computer. Or even bigger room, 20 feet by 20 feet before you install a computer. That was how we were some thousands of years ago. But as technology continued to improve, we came to an era where these big computers were made to be smaller. Smaller in the sense now that time we came to a computer, those type of computers that is just like what I drew on the board. This one is what we call the casing of the CPU. It can be standing like this. It can be standing like this. Or it can be flat like this. Then the television aspect is this one here. That was how it was some thousands of years ago. This thing I draw on the board is the CPU. The CPU can be standing or it can be flat. Just something like this. What I have here. This is it. Something like this. This is how it was some thousands of years ago. Then the television aspect, called the VDU, we are so big, as big as the old model television. Later, as time moved on, it was later reduced to what you have here. That's how we came to this stage. Now, the one will put information to tell the computer what to do and what not to do. The typewriter, the keyboard. Everyone knows how the keyboard looks like. The keyboard is just something like this. This is the keyboard. These are that time, that was how it was. Life continued. Technology continued to improve. It came to a time, after much improvements, all the components used to make computer, those of them that were, those components, like ICs, integrated circuit, capacitors, resistors, etc. These are very tiny, all those tiny things. For instance, if you look at this is the engine of a laptop. All these tiny small things you are seeing here, that's the things I'm calling different names. Integrated circuit, capacitors, resistors, and so on. Listen, is beyond the scope of this course. What we are doing is computer science, not computer engineering. So I only make mention, it's only those computer engineers that learn each and every one of these, what is it, how it is made, and all whatnot. As knowledge continued, mankind continued to do research to reduce all these components used to make computers. Then we came to the era of laptop, which is very common. That's the one we met. You can see the laptop. This is the laptop. It comes with different forms and model and sizes made by different companies. What I'm holding here is Compaq. The company called Compaq. They did this one. Now, with this miniaturization made by all these parts, this big one you're seeing here, this casing, that is this one standing here, is not this one. This television aspect, that is this one, the monitor, which is this one, is now compressed to be here, which is here, this one. This keyboard you see here, look at it, is now compressed, made as small as possible to be this one. This is the keyboard. That is all these things I'm saying. The language of the computer, that's what the language is called it. Miniaturization. Miniaturization means making something as small as possible. This laptop I'm holding here, the engine, what is inside the engine, is brought out from this laptop. Look at it. This is called the motherboard or the main board. So please, computer has its own languages and its terminology. So you'll be paying attention. As I move along, I'll be mentioning the terminologies. Because as you enjoy computer, we handle them. Now, again, look at this. This is the engine of this laptop. Now, as life continued, this laptop, which I've shown you now, was made now smaller and smaller again. To the extent now that we have computers of this one. We call it handset. Whether handset, we call it Android phone and all whatnot. They are all computers. They are all computers and they work based on the same principle. The one I'm holding on my hand now is I hold it on my hand, you call it handset. So call it a palm top and all whatnot. It goes with different names. But what you understand is that they are all computers, no matter how big, no matter how small. That is how we came to this era. Now, these computers I've drawn on the board. You can also imagine it from this another angle. You can look at it. This is the CPU. This is the monitor. You can see this. This is the monitor. It is placed on top of the CPU, flat CPU. This is the keyboard. These are other connections, the printer, the microphone, the mouse, and joystick, and or whatnot. Now, we are coming step by stage. This CPU, which is either standing, this CPU, which is either, this one is either standing or flat, but this one is flat, resting. Now the monitor is kept on top of it. Some other CPUs, these are not standing CPU, you can see it. A CPU that is standing. These are not standing CPU with the inside open. These are not standing CPU with various connections. Open is inside. These are not standing CPU. Exactly what I have here on the board, on the table. Now, connections have to be made. Whatever you tell the computer, you have to tell the computer through this keyboard. Through this keyboard. So whatever you're going to tell the computer must pass through this keyboard. So the keyboard, you see here, must be connected to the CPU at the back, the connection at the back. Here the CPU is called the keyboard is called the input device. After we input into the CPU will process it and reply to you and tell you back through this monitor. So there must be a wire connection from the back of the CPU or from the side to the what? To the monitor. So this is the starting point. There must be a connection. Take note. You enjoy computer more, handset more, when you understand the technology or that goes inside the what you're holding. We enjoy these things, we love them. What goes inside as you're holding them. Some may be interested to know, and it's very necessary. The terminology associated with all these computers. That's why we're here. Now, so we talk to the computer through the input device. Example is the keyboard. So there have to be a wire connection between the keyboard and the CPU. CPU. This is the casing of the CPU. But at times we just call it the name CPU. The CPU is inside it. We'll come to that. Inside it, if you open it, inside it, we'll come to that. CPU means Central Processing Unit. When you give instruction to the Central Processing Unit, it will process it and give you a reply through the keyboard, through the monitor. Another name for monitor is Visual Display Unit, VDE, or monitor. So this another general name for all this is the word output device. You give it for information here, this input device. You get reply here, output device. What goes on in this CPU is what we call the processing unit or processing section. Now, this brings us to an important discussion about computers. Every computer has an input device or section. Input device. What comes out is output device. Then here, what goes on here is what? Processing device. What goes on here is processing. For this, the way I wrote it may be confusing. No, confusing. Processing device. Now, what are the output device? What are the input device? What are the processing device? Now let's look at them briefly. Human beings, why do we need computer? Human beings need computer in order to process information. This device, input output, I have to write it like this, I/O. Input output device. Input is e.g. keyboard. Example is keyboard. Example is what? Monitor. So let's look at this properly so that you get a better understanding about what you are doing. Now, let's look at how we started. Why do we need computer? Do we need computer for the sake of we need computer sake? Is there any purpose these computers are serving to us? Mathematically, let's start from computer and mathematics. Eight is a number. 6 is a number. This 8 and 6, which you put into this computer, we refer to them as what? Data. When data is processed, it becomes what? Information. Processing depends on how you want it. Information. What processing have I done between this 1 and 6? The processing I have done here is what? addition. You can process 8 and 6 in another way. Processing here is not times 48. This is that data. This is what? Information. This 8 and 6, you can process it another way. The same 8 and 6 being data. Processing is minus. You get 2. Take note. This is data. Why what came out what? Is information. So when data is processed, it becomes what? Information. This thing around of processing of data, we only need to input this data 8 and 6 using the keyboard. On the keyboard, you press a quality sign like this, or depending on how they make it, enter sign. At times they do like this with an arrow. You press it 4 and 6. You press the enter key or equal to key. Press the plus key, you get 14. This time around is what you need just to put the data. It's not more your brain that is the brain that is doing it. You put the data, press the plus sign or equal to, and then equal to, then 14 will come out. Processing data and what? Information. Now, as I earlier told you, if you look at the inside or engine of a computer, the inside or engine of a computer, you see things like this. What these are things you are going to see. As I told you, it's computer. Those that study computer engineers, there's no study what goes on here. Each and every of these components, what is this for? They are connected by tiny wires from one component to another component. Those tiny wires that run like this. Tiny wires, very tiny. They are electronic highways carrying charges and electrons from one component to another. So this is the work of those that study computer engineers. They know more about this. And all these things are, if you open the inside of old television, you see those type of things, integrated circuit, resistor, capacitor, all those things are not whatnot. These are the things that are used to make this engine of a computer. So we are not going into that aspect. One other thing about this thing we are talking about this data and information. One, this data can be stored, whether data or information. It can be stored in the computer memory. It can be stored in the computer memory, whether data or information can be stored in a computer memory. Once you store it inside the computer memory, it can stay there for thousands of years. Anytime you want it, you come and call it out. 2, computer operates at a very high speed. That's another thing that makes computer lovely. It operates at a very, very high speed. At what speed does it operate? It operates at the speed of light. The speed of light is what? 300 million meters per second. Or simply, people write it like this. Or 3 times 10 to the power what? 8 meters per second. How do I explain this to a layman? If you have a coil of wire, this is 300 million meters per second. A coil of wire that goes round the world, no matter how long, and that coil of wire is 300 meters, 300 million meters, 300 million meters. You know the size of a meter. 1 meter is this. This is a meter road. This is 1 meter. This is 1 meter. So you get 300 million lengths of this of wire type of this. Put a bulb here, electric bulb here, electric bulb here. Put a switch here. Immediately you turn this switch, lights will shoot again. Notwithstanding how long this thing is, 300 million meters. So that is the speed of light, and that's the speed that which the computer uses to process data or information. Data is what you put in, information is what comes out. But at times, this word data can be used anyhow. It can be used both as information and as data itself. So, computer processes data and information. A computer has memory, which it can use to store information or data for thousands of years. It operates at a very high speed. It can make comparison. A computer can make comparison. It can make comparison. This is another aspect of computer used in decision making. It can tell you two things. Is this equal to this? Is this less than this? Is this less than or equal to this? That is this mathematically right like this. Is it greater than or equal to this? And so on. This is aspect why we use computer for decision making. We are coming to that. Decision making. What do I mean by decision making? We are all human beings. At one time or the other, we are bound to make one decision or the other. Decision making. Do I do this or do I do that? You are going to on a road like this, so two roads. You won't go like this. You won't go like this. And you are at this point. This road A, road B. The place I go, you can go through this way or you can go this way. What will guide you to know whether you follow A or B? That is decision making. The reason why you make decision is what? Everybody would like to make a decision in order to avoid chances of failure. We'll come to that. So we use computer can make comparison. That's why it's very, very good in decision making. 2, it can obey a set of instructions. 4, a computer can obey a set of instructions. Once you put in the instruction on the keyboard, type the instruction on the keyboard, and then allow the press enter, let the computer do. If you follow that instruction you gave it, you can do this way. When it gets there, it tells you this. Depending on what you want it to do, it obeys a lot of instructions. We can come to that also. And again, one other good thing about computer. As human beings communicate, as I'm here, I'm communicating to you. You are in one part of the country, like Africa, you are communicating with somebody in America or in Asia. As human beings can communicate, talk to each other, 2 or more computers can communicate to each other. 2 or more computers can communicate to each other. This is the advent of the internet. I'm talking about internet. We are coming to all this. Now, these are the various things the computer can do. And that's why computer is very, very necessary, especially in this age. The processing of information, human beings need information. Very, very important. We all need information. When I was talking about this information here, information about, different type of information will determine what you want. Let me give you another example of data and information. Let me give you another example of data and information. 3, 5, 6. This is data. Data. what I have here is what? 4.7 information. What did I do? What is the process that took place here? Average. In mathematics, you know how to find average. Add the numbers 3, 4. Add the numbers 3 plus 5 plus 6. The how many? 1, 2, 3 divided by what? 3. If you do it, you get what? 4.7. This time around, it's not your brain that is no more doing it. Only input 3, 4, 5, 3, 5, 6 with the keyboard. Then press the key you're supposed to press. The 4.7 will come out. That's the information. So that stress of using your brain to do whatever you want to do, computer has taken over from you. When the quantity to be done is very, very large. Here is only 3 data. 1, 2, 3. And so this is 70, 80, 100, thousands. Is you able to use your brain to know? Computer will just do it and give you the answer at the speed of light immediately. 6. These are another data and information. These are another data and information. 6, 4, 9, 1. This data, information. 6, 9. What processing have I done here? I have arranged it in ascending order. Arrange in ascending order. This is data, this information. It comes in different forms. It comes in different ways. Therefore, whenever a set of data, be it numbers or alphabets, is processed, making them more organized, giving a more detailed fact, as quite unlike when it was before. That is, when data is purified, the outcome is what? Information. An analysis of data gives us what we call information. The input say on a computer keyboard is data, while the output comes out in the form of what? VDU. They call the front of the screen the VDU, the screen. We call it VDU or monitor. This is the output. From what I've seen now, you can see that what enters in as data is different from what comes as information. That's what we call it garbage in, garbage out. What you put in must be different in one way from what comes out. That's information. If you put in, say, let me say, 7, 8, 9. When you get processed, when you get processed, you get to again 7, 8, 9. Processed. After processing, you put in 7, 8, 9 as data. It comes out information at 7, 8, 9 again. Nothing has been done. But computer is such that this side, the data side, will be solely different from what? The output side. What goes in was different in one way or the other from what comes out. You can see here what goes in here, and 4.7 will get. Here, 6, 4, 9, 1. But this time when it came out, it does not get rearranged. 1, 4, 9, 6, 9. And so on and so forth. This is the reason why, another important language, this is the reason why we call computer a system. A system. That's the language, these are terminologies you normally hear about. I give you my system. He carried my system. What is your system? System is a situation where whatever comes in must be different from what comes out. As human beings, when we eat food, carbohydrates, protein, we drink water, etc. What comes out is what? Waste excreta, urine, sweat, etc. So, what comes in must be different in one way or from what comes out. That's what makes something a system. In the university, when you enter the university, when you are going to do a degree course, 4-year degree course, year 1, after you have stayed in the university for 4 years, depending on the course you want to do, you come out now with a degree called bachelor's degree, BSc degree. This was a system. By the time you enter year 1, you are more or less like a raw material. Having stayed in the university for 4 years, you have taken different courses, so and so, because so and so, like a number of courses you do, at the end you come out with a certificate called BSc degree. What entered here is different from what course outside, is a system. All manufacturing companies are all systems. For instance, cutting wood, if you put cutting wood in the machines inside the company, at the end, this cutting, when it's processed, what comes out is what? Textiles. That is cloth. The textiles used in making cloth. So what goes in is different from what comes out. So in secondary school, if you enter secondary school from, I don't know which country you are, after you enter secondary school, secondary 1, by the end you complete the 6 years in the secondary school, you come out with a certificate called WAEC, SSCE, Cambridge, and so on. All these are examples of what? A system. So the reason why we call this computer a system is what? What you input in, called data, is different in one word or the other for what comes out, which is information. Once what goes in, undergoes some process, comes out is different. Such a thing is referred to as system. So when you see people calling all these things system, and you are taking my system, if I need my system, all these are systems. You understand the reason why they call these things what? System. So this is the first lecture under computer science. Now, next time, we now look more about, we dig deep into the theory behind computer science. Thank you very much.